connected, strongly connected, and weakly connected graphs. What is a connected graph? In a connected graph, all vertices should be connected through edges. What we'll do is we'll draw a graph and then we'll understand from it at what point it becomes connected and at what point it is not connected. So this will be interesting. We'll have these vertices. So once I complete the graph, you have to see whether it is connected or not connected. These are my edges. I'll name the vertices as A, B, C and D. If this is my graph, is it a connected graph or is it not connected? It is a connected graph because you take any two vertices from this graph, you'll see edges that connect those vertices. Now the question is, if I remove these two edges, is it still connected or is it not? So the answer is, it is still connected because, see, it may seem like there is no edge from A to C, but for a graph to be connected, you just want the edges to be connected by any path, not necessarily by a direct path. So here, if you want to reach from A to C, you can go from A to B and then from B to C, which means you still have a path through some edges from A to C. So if you have some way of reaching from one vertex to any vertex, that is, for all the vertices, there should be some way of reaching from any random vertex to any other random vertex. If that is there, then you call the graph as connected. So next thing is, if I remove one more vertex from it, if I remove this as well, is it still connected? It is still connected because if I want to reach from C to D, I can come from C to B, then B to A, and then A to D. So it is still a connected graph. Then the question is, when will this be not connected? When will you consider this as a disconnected graph? So a graph is not connected only if it has isolated subgraphs or if it has isolated vertices. So I'll show you when it will happen. If this is your graph, let us say you have one more edge here, two edges here, and this vertex is E. And maybe you'll have one more vertex here. If this is your graph, and if I remove this edge AD and edge BC, this is now a disconnected graph. It is not connected because there is no way to reach from any of these parts of the graph to any of these edges, these vertices. So this is a single graph. It is not two different graphs. It is still a single graph with two subgraphs, but it is a disconnected graph. So this is when you call it as disconnected. For example, from A, there is no way to reach from A to C, or maybe A to D or A to E. So only when you have a case when there is no way of reaching from some vertex to some other vertex, then only you call it as not connected. What is another situation? Another situation is if you have a graph like this is connected, and you have one isolated vertex here. This vertex is not connected by any edge. Then this is a single graph, but it is having two subgraphs. One subgraph is this, which is connected, and another subgraph is this vertex alone. So this complete graph, which includes two subgraphs, is not connected. So these are the only two situations where your graph will be not connected. One is it is having two isolated subgraphs. This is a subgraph. This is also a subgraph, but these two are isolated from each other. Another situation is if you have even if you have a single isolated vertex, that is also considered as a graph which is not connected. Okay. So this is only when you will see a graph which is not connected. Next question is about when is it strongly connected? When is it weakly connected? So in order to go there, till this point we were only looking at undirected graphs. But the concept of strongly connected and weakly connected, that comes up in directed graphs. So if we consider it as a directed graph, in case of directed graphs, when will it be strongly connected? It is strongly connected if a path exists in both directions for every pair of vertices. So let us see how this is. If I have a graph like this, A, B, and C. I'll have directed edges here. From C to A, I'll have an edge. From A to B, I'll have an edge. From B to C also, I'll have an edge. In this case, is this graph strongly connected? The condition is there should be a path which exists in both directions for every pair of vertices. Is it satisfied or not? So it is satisfied here because you take any two vertices. Let us take A and C. If I want to go from A to C, I can go from A to B and then from B to C because I have a directed edge from A to B. I have a directed edge from B to C. I can reach from A to C. If I want to reach from C to A, I have a direct edge from C to A. So I can directly reach from C to A. So in this graph, if you check any two of the vertices, there is a way of reaching in both ways. That is, you can reach from first vertex to the second as well as second vertex to the first. So in both directions, if path exists, then you call it as strongly connected. That is for every pair of vertices. Take any two vertices from it, there should exist a path which is in both directions, from one edge to the other, one vertex to the other, as well as back connection from this particular vertex back to the initial vertex. So if both are possible in some way, then you call it as strongly connected. Okay. And what about weakly connected? Weakly connected is when replacing all the directed edges with undirected edges results in a connected graph. Then that is when you call it as a weakly connected graph. So whatever we learned initially about connected graph, that was about undirected graphs. So now you have a directed graph and we are saying if you have path to reach from any vertex to any other vertex, and also in the reverse also from the second vertex also you can reach to first vertex. If all the paths are available, then you call it a strongly connected graph. And if you consider this strongly connected as an undirected graph, and then if it becomes connected, then you call it as weakly connected. So this is the concept of weakly connected graph. You just consider the present strongly connected graph as an undirected graph. You just imagine that the directions are not there. Considering it as an undirected graph, if it is connected, then it is called weakly connected. I'll give an example. If instead of this, you had, let us say, same vertices A, B, and C, and the direction you have is from A to B, you have an edge, and let us say from B to C also you have an edge. If this is the situation, then this is weakly connected. Why is it weakly connected? Because if you want to reach from A to C, you can as of now come from A to B and then B to C. What if you want to go from C to A? There is no path, so it is not strongly connected. But if I remove the directions, from here, then I can come from C to A. I can come from C to B and B to A. So if I remove the directions, if it will become connected graph, then it is weakly connected.